the concept of potential and potential difference. Electrical potential is a concept that can be slightly tricky to understand as it is often difficult to visualize. So let's try to use analogies to gain some insight into this concept. Imagine a large tank filled with water to a considerable height. This water contains energy in the form of gravitational potential energy. This water is not moving, it is stationary, but it can move and perform work under the right circumstances. If we were to connect this filled tank with a pipe to an empty tank, the water would flow from the first tank into the second one, and the flow would continue until the height of water in both tanks equalized. This means that the water in both tanks now has the same gravitational potential per unit mass. If we now look at electrical circuits, we understand that just as water flows from high gravitational potential to low gravitational potential, electrical current flows from high electrical potential to low electrical potential. But what is the source of this electrical potential energy? The source of electrical potential energy can be chemical energy if you are using a battery. It can be light energy if you are using a solar cell, or it can be mechanical energy if you are using a dynamo. In other words, if we can create an imbalance in the electrical potential energy between 2 points in a circuit, we can cause a current to flow from a high potential to a low potential. Looking back at the water analogy, we know that when that tap is opened, the potential energy of the tank is converted into the kinetic energy of flowing water. Thus, the water in the tank is doing work. In a similar manner, the electrical potential source in a circuit, whether it is a battery or a dynamo or a solar cell, is doing work when it causes charges to circulate in a closed conducting path. Similar to a water pump, pumping water in a pipe, for each unit volume or mass of water being pumped, the pump is performing some amount of work. In the same way, potential difference can be conceptualized as the work done in moving a unit charge between 2 points in a circuit. Electrical potential and potential difference are measured in joules per coulomb. More conveniently, 1 joule per coulomb is equal to 1 volt of potential difference. But what does that really mean? Let us say that we have 2 points A and B, and they have an electrical potential difference of 1 volt between them. What this means is that in the movement of a coulomb of charge from point A to point B, the potential source has to perform 1 joule of work. So how do we measure voltage? Well, there is a device. Just as we use an ammeter to measure electrical current, we use a device known as a voltmeter to measure potential difference. An important thing to note is that while an ammeter is placed in series with the circuit in which we are trying to measure current, on the other hand, a voltmeter is placed in parallel across 2 points whose voltage difference we need to measure. Please remember, potential or voltage difference is always found across 2 points.